Okay, ladies and gentlemen, we're starting chapter 10 today, and today this chapter is going to be going a little bit more into square roots. So we have a square root function, which is when the variable is under the radical sign. I'm just going to list the symbol there. That's the radical sign. So a radical function is a larger group of functions that contain different roots. So you could have a cubic function, which would then be the cubed root of the variable. You could have a fourth root function, which would then have it. But we really only need to deal with square root functions, which makes it a little easier. So the radicand is the number under the square root symbol. So if this is x, x would be the radicand, which is kind of a silly word, I admit. So when we graph these, so this is another type of function that you need to be able to recognize the graph from. So we have linear, quadratic, exponential, and now we have square root functions. So they start here. Notice you can't have x be a negative number because we can't take the absolute value, or sorry, we can't take the square root of a negative number. So they stop right here at 0. Of course, we're going to be able to move them, but we'll get there. Your domain is going to be x is greater than 0, and your range is going to be y is greater than or equal to 0. All right, so let's take a look and see. I'm going to start by just making a chart. So here I have the function g of x equals 4 times the square root of x. So I'm going to start by putting some numbers in. 0, 1, 2, 3, 4, 5. Now, some of these are going to end up being decimals. But the square root of 0 is 0, and 0 times 4 is 0. Okay. Square root of 1 is 1 times 4 is 4. If I do the square root of 2, and I'm going to have to approximate this, which is 1.4, and then if I multiply that by 4, so you're getting about 5.7. All right, so then the square root of 3 is 1.7, and then 1.7 times 4 is 6.8. And then the square root of 4 is 2. That's a perfect square. And then 2 times 4 is 8. And then the square root of 5 is 2.2. So then 2.2 times 4 is 8.8. So now I'm just going to graph those. So we have 0, 0. 1, we were at 4. 2, we were at 5.7, so you're approximating. 3 was 6.8. 4 was 8. And then 5 was about 8.8. So you'll see that it's going to start going like that. Okay? Hopefully nothing too difficult there. All right, let's see what we have on the other page. So this is now talking about how we can translate the graph, and the rules are exactly the same as we did for our quadratics. This tells you that the graph starts at the origin, and then it's going to make it kind of go either compressed or, compressed or down, stretched. I apologize, guys. The one at the end is going to move it up or down, and then the inside is going to move it left or right. So it tells you to kind of start by drawing the graph. So, and then this is a negative, so now it's going to be flipped over. So it's still going to start at 0, 0. Okay. Then if I take this just the square root of x function, well, the square root of 1 is 1, but now I need to make it negative. Okay, then I'm going to have the square root of 2 is about 1.4, but again, I have to make it negative. So that's going to be about here. And then the square root of 3 is 1.7, and again, I have to make it negative. And then the square root of 4 is 2, make it negative. That's a pretty bad, you kind of can see. So it took our function and it reflected it over the x-axis. Because now let's kind of sketch our parent function here. Right, our parent function kind of looked like this, and so it just got reflected. Okay. So here, normally I would take, and I would have to start at 0, 0, but now we're going to take it and we're going to move it up 2, because I've changed my my y-intercept, right? So that's going to go up a little bit, but then it's going to be the same, you know, I'm going to put this one in blue up here, just so that we can see kind of what's happening. Right, so now I'm going to have everything be moved up by 2. Right, same function as the blue one, I just took it and slid it up a little bit. This is going to now take it, and remember this is where we do the opposite, so instead of it looking like it's going to go to the right, it's actually going to go to the left. Right, so if I put 0 in for x, that's really the square root of 2. So 0 square root of 2 is going to be 1.4. So we're at 0 and 1. So now, because I can have, to get my 0, I could put negative 2 in. So now if I put negative 2 in for x, I'm going to be here, and then if I put in a negative 1, I'm going to be here, and then we start, again, kind of going up. Right? So that one, again, you can put it in your calculators and check it just so that you can see it really does work. All right, so now let's see here. I want to graph this and compare the graph to the parent function. State the domain and range. Well, I already know, again, I'm going to start with my parent function, just so that you guys can appreciate what's happening here. I now need to flip it over the x-axis, and this 2 means that it's going to be a vertical stretch, right? This tells me that I have to go to the right 1. So I already know that this point here is going to get shifted over, right? Because I can't put a 0 in, it's not going to work. If I put a 1 in, right, 1 minus 1 is, oh, I did that, sorry. If I put a 2 in, 2 minus 1 is 2, oh God. 2 minus 1 is 1, which is the square root of that, and then that number is going to be a negative 2. And then we're going to take, right, so it's kind of making it longer. If I put a 3 in, 3 minus 1 is 2. Square root of 2 is 1.4. 1.4 times negative 2 is going to give me negative 2.8. And then if I put in the 3, 3 minus 1 is 2. I just did that one. How about 4 minus 1 is 3? And then if anyway, I hope you guys are seeing what's happening here. So now, instead of it going like this, we've shifted it, and it goes like that. Then they want us to state the domain and the range. So the domain, right, I can't have underneath the radical sign be a negative, which means your domain has to be all x such that x is greater than or equal to 1. Because if I put in a 0, I'm going to end up with a negative. Right, so this changes it a little bit. My range, right now, because it's not up here in the blue, it's down in the green, my range is all y, such that y is less than or equal to 0. All right, I think we're going to save the word problem, because this video has not been going well. I fully admit that. We'll save that for tomorrow, but a lot of it is calculator work. This is still the same rules as before, right? The number out front tells you is it a vertical stretch or compression. If it's negative, it reflects it over the x-axis. K tells you is it going up or down. H tells you if it's going right or left, and those are the opposites. So exact same rules as our quadratics. All right, guys, I will see you in class on Tuesday. Any questions, bring them with you.